So Unit 1, Lesson 3 and 4, a Grade 9 review of linear relations. So you may recall from Grade 9 that we had studied the equations of lines. And you may remember one in particular called the slope y-intercept form. The slope y-intercept form was the form that we used to help us graph a line. And so you have your y and your x, which are the two variables, your independent and dependent. Your m is representing your slope, a rate of change, and that was a constant value. And b is also a constant value. It also represented our y-intercept or our initial or starting value. So we're going to do some examples on graphing lines. So here's our first equation, y equals 3 over 2x minus 4. So you may remember this 3 over 2, this is our slope. So slope is represented by m. M is 3 over 2. And having the fraction helps us draw our slope on the graph. The top number on our fraction is a representation of our rise, and the bottom number of our fraction is a representation of the run. I'm going to show you how that, or remind you how that looks like. Minus 4 is what we call our y-intercept or our starting value. So on our grid right here, we're going to start by labeling our axis. So we have an x-axis and we have a y-axis. And we know the y-intercept, where the graph crosses the y-axis, is right here at -4. So I'm plotting a point at -4. Now, using that point and using our knowledge of the slope, I can find another point on this line. So every grid square here, it has a value of 1. So if my rise over run is 3 over 2, I'm going to rise 3 squares, so 3 units. 1, 2, so here 1, 2, 3, and then my run is positive 2, so I'm going to go to the right, positive 2 units or 2 squares, so 1, 2, and right here is where I'm going to plot my next point. And I can repeat the same thing again by going from this point and rising, so from this point rising up 3, so 1, 2, 3, and my run is positive 2, so to the right 1, 2, and there I'm going to plot another point. Now you only need 2 points to make a line, and so I have 1 extra point here, but that will help us draw the line anyways. I'm going to connect my points and create a line. So here we go. Extend it a little bit. Right there. Okay. So there's my line. I show the 2 arrows at opposite ends to show that to indicate that the line continues in both directions. And there you have it. There's your line. You can verify your slope once more. Just show that here's this triangle, and here's a slope of rise of 3, and here's my run of 2. Okay. All right, so let's try another one. So here's another equation of a line. Now this is not in slope y-intercept form. This is in standard form. Okay, standard form, as you recall, looks something like this: ax plus by plus c equals 0. Now it's not easy to graph this standard form equation, but we can convert it to a slope y-intercept form by isolating y by itself. Okay, so you need to follow your equation solving steps to isolate y. So to do that, I'm gonna leave 4y in my left side. Okay, I'm gonna add 8 to both sides. When I add 8 to both sides, minus 8 on the left side disappears, and I have 8 on the right. And I'm gonna subtract 3x from both sides. So if I subtract 3x on the left side, it'll disappear, and I'll have minus 3x on the right side. Okay. So I'm almost there. I need to remove the 4 so I can get y by itself. So I have to divide both sides of the equation by 4. So if I divide by 4, 4y divided by 4 gives me y. And on the right side, I have 8 minus 3x over 4. Now I'm going to separate the right side into 2 independent fractions. So y equals 8 over 4 minus 3 over 4 times x. And I'm just going to put the x term in the beginning. So minus 3 over 4x plus 8 over 4. But I can simplify 8 over 4 to being 2. So now I can see that I have a slope of -3 over 4. and a y-intercept of 2. So going to my grid here, I'm going to plot my y-intercept. So here it is at positive 2. Now the slope is negative, so instead of going up, my rise is going to actually go down, so minus 3 units. I'm going to start from my positive 2 value here and go down 3 units. 1, 2, 3. The 4 in the bottom is still my run. It's considered positive, so I'm going to go to the right. 1, 2, 3, 4. And I'm going to plot my next point right there. Okay, you can repeat the same idea and make another point. So you go down 3 and then to the right 4 and plot your point. And then you connect your points with your straight line. Okay, and you can extend the line if you like, but as long as you show the 2 arrows in both ends, it indicates the line continues. All right, so let's try another one. Graphing this. Again, this is not in y equals mx plus b form, but you can convert it by rearranging the equation a little bit. So isolate for y, so I leave the 4y on the left side. I subtract the 2x from both sides of the equation. So if I subtract 2x on the left, that disappears. And then I subtract 2x on the right to balance it out. Then I divide both sides of my equation by 4. So y equals 16 minus 2x over 4. And I'm going to separate the two into the right side into 2 separate terms. So 16 over 4 minus 2 over 4x. And then I'm going to just bring the x term in the front. So minus 2 over 4x plus 16 over 4. And then lastly, I'm going to put this in lowest terms. Oops. Okay, if I put this in lowest terms, I will have y equals what happened there? Okay, so y equals 2 over 4 can be written as negative 1 over 2. And 16 over 4 is written as 4. 16 divided by 4 is 4. Okay, so if I plot this on my grid, here I'm going to have 4 as my y-intercept. My slope is negative 1 over 2, so I'm going to go down 1 and to the right 2, plot my next point, down 1 and to the right 2, plot my next point. And then I can connect my points with a line. Like so. Okay, and then I'm just going to erase the triangles there. All right, so there's my line. Now let's look at one more example. Determine the equation of the line going through the points negative 8 and 1 and negative 9 and 2, and then graph the line. So negative 8 and 1 is right about here in my grid, and negative 9 and positive 2 is right here in my grid. Okay. Now you can see that from this point to this point I have a slope of negative 1, so m equals negative 1. But if you wanted to verify that using the slope formula, you might recall the slope formula is the difference in y values over the difference in the x values of your 2 points. So if my first point, let's call negative 8 and 1 was x1 and y1, and negative 9 and 2 would be x2 and y2. So if I plug these values into my equation, y2 minus y1 would be 2 minus 1, and x2 minus x1 would be negative 9 minus negative 8. And so 2 minus 1 is 1, negative 9 minus negative 8 is negative 9 plus 8, which is negative 1, and that's equal to negative 1. So I was verified my slope is negative 1. Now, what's the y-intercept? Well, if I took the equation of a line, y equals mx plus b, and I substituted one of my points, let's say negative 8 and 1, so 1 is my y value, negative 8 is my x value, and I already know the slope is negative 1, so I put negative 1 in front, and then I can proceed to solve for the only unknown quantity in my equation, which is b. So if I solve for b, this is what I'm going to get. Negative 1 times negative 8 is positive 8. So 1 on the left equals 8 plus b. And so what does b have to be? Well, I have to make b negative 7 for this to work, right? So b is equal to negative 7. So that 8 minus 7 equals 1. So in my grid, I plot negative 7. And then I can continue connecting my points to complete the equation of the line. right there. Okay. And there you go. And so I want you to practice graphing some equations of lines. That ends this lesson.